Ladies and gentlemen, hello and welcome back once again to the Operational Intelligence Overview here at InsideAnalysis.com. My name is Eric Cavanaugh with the Bloor Group, and I will be your moderator for today's demonstration, which is some very interesting stuff from ExtraHop Networks. We have Eric Thomas, and in the background we've got Eric Giza and Justin Baker as well. So, gentlemen, show us what you've got.
All right, thank you, Eric. So what I'm going to show you today is a zero configuration install of an ExtraHop appliance. So essentially, if you took one of our virtual appliances or physical appliances, plugged it in, gave us a data feed, this is what you'd see. So what we're looking at right now is our summary screen. It is a per-user configurable dashboard. Every individual user can add whatever data they like to this screen. It's made of these widgets that you can add and remove. You can make them bigger or smaller. What I have up at the moment is a series of overview widgets. So these are at a very high level what's going on in the entire data center, every single transaction across every single tier. So show me all of my HTTP, show me all of my database traffic, all my DNS. For every protocol that ExtraHop supports and parses, which is essentially the entire application delivery chain, we're analyzing every single transaction in real time and doing automated analysis on those transactions to bubble up usable, actionable performance data. ExtraHop is an operational intelligence platform. So while we surface performance data, we're also looking at data that's useful for capacity planning purposes, for security use cases. We can even measure SLA performance and estimate penalties against SLAs. The point is that you can use this data for whatever you like. Essentially, we're giving you visibility into your operations so that you can have clarity in real time as to what's happening in the data center. So in terms of how we're gathering this data, we're a 100% passive monitoring tool. We don't install any agents on servers. We don't install probes. We don't create users on database servers. Essentially, we're taking a copy of every single packet on the network, so literally every single Ethernet frame. We're assembling that up into the TCP conversations of which those packets are a part. So we call this full stream reassembly. We are simulating the TCP stacks of every device in the data center, whether physical or virtual. And then we take all those conversations and we run them through a series of protocol parsers to identify what types of transactions we're looking at. So for example, if we see that a device on the network is responding to HTTP requests and putting HTTP responses back on the wire, we'll say, okay, we can tell that that is a web server, and we'll categorize it accordingly. Now, if we also see that that web server is making requests to a database tier, we'll also categorize that as a database client. And so as we analyze all these transactions in real time, we are building up sort of a service-oriented model of the data center according to which machines are offering which services to their peers on the network. Now, we analyze that data and present it to the user according to three sort of broad categories. We have our reporting and visualization views. This summary screen is an example of that, but we also have custom reporting, flexible UI configuration, scheduled reports, that sort of thing. So that's the first category. The second category is an application view. So when people in technology companies that are responsible for the health of technology operations talk about what they're doing, they talk about applications. They get down to servers and networks and switches eventually, but broadly speaking, they talk about applications. And so we categorize applications in the data center essentially by looking at every tier of that application and then sort of distilling that into a picture of application operations and application health. So for example, what I'm showing here is a sample application, an app store, and we are looking at performance for the web tier, the database tier, and the storage tier. And for each one of those tiers, we are showing the processing time, so the time spent just kind of chewing on the request and putting together a response, as distinct from network time. So round trip time is a measure of network latency, and then request and response transfer time are the time that those requests took to traverse the network. So by looking at this sort of cross-tier view of the application, I can answer a couple of questions very, very rapidly. Number one, which tier? If I'm having a problem, where is that coming from? And number two, for that tier, is it the server or the network? And by answering those two questions immediately in real time, we can obviate the traditional way of identifying the source of those problems, which is, essentially to spin up a conference bridge, invite all your siloed engineers, onto that bridge and have them look at their point tools, kind of try to sort it out over 2, 4, 6 hours. I personally was once part of an 18-hour conference bridge that attempted to answer questions like these. And so with ExtraHop in real time, for example, we can see that this storage tier is having issues within the disks themselves, right? Because the access time has spun up. And we can drill into that access time to understand which individual files are responsible for it. At the web tier, we'd be looking at URIs. At the database tier, we'd be looking at database calls. And we can say not just, which tier and server or network, but, for example, for storage, maybe I need to go rearrange the LUNs that my files are living on. Maybe I need to rebalance my cluster. So we can give you actionable data to go resolve those problems very, very quickly. And for each tier, we allow you to drill into that tier. So once you've looked at your overview, you can dig very, very deeply into individual aspects of all those transactions. So we can look at every single URI, every web transaction, and understand which ones are popular. We can understand which ones are fast or slow. So this processing time is the mean transaction time. The black tick that you see is the mean, and the orange bar is a standard deviation for understanding how consistently these transactions are returning in a particular time. And then we combine those two for a total. So which pages are both popular and fast or slow. So if I want to find out where my slow transactions are, I sort by processing time, and there I have it. I found my slow stuff very quickly. And this applies to sort of every tier that we measure. Now, a quick word on how you might react to this data in an operational scenario. We maintain an alerting engine that is based on statistical analysis of time of day, day of week, and day of month patterns. And we keep a 5-week rolling baseline to understand month-over-month trends as well. So what we do with that is we can alert you, based on thresholds, the traditional way of doing alerting, but much more powerfully, we can alert you based on deviations from norm. So we can catch problems as they are beginning to occur, as opposed to when the customer is already calling you, because we can watch when things go out of tolerance. If that application has very tight tolerances, as with, for example, payment processing systems, we can tell you that 50 milliseconds is okay and 55 milliseconds is catastrophic. Or, for let's say a reporting engine in CRM software, we can tell you that, this transaction is a report. It's okay if it takes 30 seconds to run. But this transaction is a search and needs to come back in 20 milliseconds. And we discover all of that automatically, and we let you know when things go away from those tolerances. So with respect to these transactions, we're looking at transaction timing, right? We're looking at error rates. So, when are we seeing a 500 error that indicates that the web server just fell over and died, couldn't fulfill the request at all? And we break those down via a series of different dimensions. So for example, if I'm looking at my 500s, there are sort of 3 things I want to know. Number 1, which transactions are failing? Number 2, where are they coming from? Is there a particular server that's responsible for the majority, or in this case, all of those errors? And then finally, who's affected? Which clients are receiving those errors? Now, again, we are taking each tier, because we are looking at all tiers of that application, and we are balancing our measurement of processing time and in-server sort of request time with network time. and showing that together. So the power is in tying layer 2, the Ethernet layer, all the way up to layer 7 and understanding the interactions between them. So for example, this graph with sort of the orange blob starting at 015 is comparing processing time against network time. Now, if I were having a network issue, I'd see a lot of green, a lot of dark blue and light blue on this graph. But at a glance, I can tell that at 015, my web server farm started slowing down. And I can understand why that is. Now, maybe that's a dependency on the database tier. I can look by a time correlation and see that at the database layer, at that same time, the database transaction rate went way, way up, and the error rate spiked as well. This histogram down here shows me the number of errors. And that is just leaping off the page at me to show me that I have a database issue. And I can look at every error for every database server in this application, or even every database server in the entire data center, to understand what those errors are and where I should trace them. In this case, we have a too many connections error, and so I can trace that to the TCP layer. I know that I have a network issue now. And just to recap what we've looked at so far, we started by just looking at an overview of the application, looking for problems, and they're leaping out at us, right? We saw a storage issue, now we're looking at a TCP issue. So two interrelated problems that are affecting this application.
Yeah,
and we can see that.
Yeah, just real quick, I'm guessing as new applications and new servers and new sources are brought into the network, I'm guessing that you're kind of sniffing those out and dynamically adding them into the mix?
Absolutely, we are. So I mentioned that we have a few different ways of organizing this data. Now I'm going to dip into what we call our infrastructure view, where we're looking at devices on the network. And we are tracking those, by name, by MAC, by IP, by VLAN. We're also looking at discovery time. So just like you said, when a device appears on the network, we're going to be reporting on that in under 30 seconds. And we can alert you too. So, when we talk about operational visibility and the variety of use cases we can support, this is a good example. A security team wants to know when a new device appears on a network, understanding rogue access points and that sort of thing. We didn't necessarily build the ExtraHop solution to support security. We built it for visibility, but a security team can come in there and discover that use case and get a lot of value out of it. Now, the other point related to that automatic device discovery is that in a highly virtualized environment, that is absolutely essential to monitoring your infrastructure. You can't have any upfront setup. It'll just kill you in terms of management overhead, in terms of staffing, in terms of reactivity to problems. I mean, if you have to run around and set up new monitoring every time, you vMotion a device from one pod to another, one data center or another, you're going to miss all of your performance impacting problems, right? So what we do is we see that the device has disappeared in one place and it has reappeared in another. It has the same IP, so we understand that it is the same device and it's consistent, but we track how its characteristics have changed as it's moved. So we'll see that maybe now it's it has more CPU assigned to it and its transaction rate is better. Right? And we can track that in real time. So great point. We're absolutely tracking kind of the dynamism of modern data center environments. So within that infrastructure view, we are grouping these devices together, and we can analyze them as a group or individually. And this is really where you get into very, very deep drill down. So in terms of this UI, we're showing, over here on the right, we're showing all of our detailed data about a certain activity of a certain group of servers. So at the moment, we're looking at all of the web servers in the environment over the last 30 minutes. We maintain a 30-plus day historical look back at a bare minimum. So that's, if you take one of our 10 gigabit appliances and load it up at line rate, 10 gig sustained, 3,000 servers under management, you'll get at least 30 days of look back. Typically, our customers are doing a bit less than that, and we see somewhere between 6 to 18 months of historical data for all of these counters that we're keeping in the appliance. So we're looking at all of our web servers over the last 30 minutes, and we're looking at web data for those web servers. So, show me every error across my entire data center in the last half an hour. So that's over here on the right. Over on the left, we're showing everything else that these servers are doing. So many of them are doing SSL, and we're looking at their SSL certificates. We're alerting when those certificates are about to expire, 90 days out, 30 days out. We're seeing that they're doing DNS lookups, right? So they're looking up the names of their peer servers. We see that they're pushing database server and client activity across the network. So the idea here is that, number one, we're looking at every tier of the application, so we're taking a holistic view, and we're looking at the network. We're tying all that together, and you can walk up and down this left navigational element to cross tiers for a particular group of devices. So in addition to our infrastructure views, in addition to our application views and our custom reporting, we have a number of other features that allow us to sort of extend the functionality of the ExtraHop device to support highly business-specific use cases. And this is where the operational intelligence platform lends itself to a business intelligence use case as well. We call this functionality application inspection triggers, and it is a way for us to define essentially custom metrics that we're collecting. And we do that by analyzing the payload of application transactions just long enough to do our analysis, and then essentially we throw that payload away. So it's never written to disk, no compliance issues there, but we can analyze that payload to bring out business-specific use cases. So an example that I'm showing here is a customer wanted to understand the performance of their website from iPhone devices versus everything else. So, Android, desktops, iPads, etc. Just show me the iPhones. So we created a little bit of scripting, and this is all packageable, by the way. It's, we can deploy this as a 2-click configuration bundle. We created a piece of config that went into every web transaction, looked at the headers to understand which browser type and which device type created that transaction, and then separated them into 2 buckets for the purposes of measuring response time. And what we found was, number one, iPhones were an order of magnitude slower than everything else. So we can see somewhere between 400 and 800 milliseconds for these transactions. And then 0 to 20 milliseconds for anything that was not an iPhone. And we took it further and helped them drill down into exactly which transactions were driving those numbers. And in this case, there were essentially 2 different pages that needed to be refactored to accommodate the iPhone browser type. We can then combine that with data from other tiers. So, we can do cross-tier analytics to understand which web transactions we're creating how much database time, for example. This is deterministic cross-tier correlation on a transaction-by-transaction basis for every single transaction in real time, which, if you're a veteran of performance management tools, you might be hearing the words holy grail in your head right now, because this is something that a lot of vendors have been trying to do for many, many years. And we can do that both out of the box with no configuration, or we can do it in a custom fashion using application inspection triggers. So that's just a very small sample of the number of use cases we can support using triggers. Others would include identifying your customer organizations and doing business level reporting, not only on their processing latency, on their network latency, so you can assist your customers in improving their connectivity, but also in terms of real money transactions. Which customers are driving how much money to my site? How many orders are they driving? How does that compare to all of my other customers on average? We can help you make business level decisions using this reporting that is highly specific to the customer organization. So that's sort of just dipping a toe in the waters of ExtraHop. We have a lot more under the hood, but hopefully this helps to give you an overview of what the platform is capable of and the size and shape of what you can accomplish using ExtraHop.
And I'm guessing, just real quick here, that when certain patterns of behavior are detected and certain problems are resolved, is ExtraHop at that particular client site dynamically keeping track of various patterns of, in other words, when some complicated problem is identified and resolved, does the end user need to manually store that, or is that kind of what you're doing with some of the device groups down there? In other words, how much dynamic learning occurs by ExtraHop on a particular client site over time?
So we're constantly maintaining statistical baselines for every single metric we capture. So we are dynamically adjusting to the performance characteristics of every application, including server components, including client components, including the network connectivity between them. Everything that is happening to make that application run, we're analyzing that in real time and dynamically adjusting to it. And so that allows us to understand that, maybe a certain end user typically gets 10 errors a day, and today that user is getting 150. Or maybe that user typically gets no errors, and today they got 1. And we can distinguish between those two conditions to understand the severity of them, right? So, if we've never had an error on a particular application or for a particular user, 1 error is a big deal. If we typically have 150 a day and we have 151, not such a big deal. And so we're learning the characteristics of those applications to remove the upfront analysis. You can almost think of it as, having 100,000 engineers doing constant packet analysis all the time and keeping that knowledge in their heads, understanding not just, what the applications are doing, but the context in which they're doing it.
Yeah, that's great. Well, this has been a very educational demo. This is very powerful stuff. Folks, we've been talking to Eric Thomas of ExtraHop Networks. And to find you online, it's just extrahop.com. Or what's the URL?
www.extrahop.com.
Sounds good. Thanks so much, folks. Another demo for the can here at the Operational Intelligence Overview at InsideAnalysis.com. Thanks for your time, guys.
Thank you, Eric.
All right, bye-bye.